Hello and welcome back to Linear Algebra Mastery. Today we're going to jump into our flashcard system, Anki. See if we got any flashcards due. We got 15 of them due. Alright. If a linear system has infinitely many solutions, what is a general solution of that system? If a linear system has infinitely many solutions, the general solution of that system is going to be essentially a set of parametric equations. A set of parametric equations in which plugging numbers into them can give you all the answers of the infinitely many solutions. A set of parametric equations for which all solutions can be obtained by assigning numerical values to the parameters. I think that's good. What are the leading variables in a linear system? Leading variables, actually I'm going to say hard on the other one because I didn't really say parameters, even though I kind of implied it. But what are the leading variables in a linear system? These are variables associated with leading ones in the augmented matrices, not augmented matrices, row echelon matrices. Variables associated with leading ones in the row echelon forms. Of augmented matrices. Good. How many solutions does a homogeneous linear system with more unknowns than equations have? If it has more unknowns than equations, it's going to have infinitely many solutions if it's a homogeneous linear system. If a matrix is in reduced row echelon form, what must be true of the first non-zero number in a row that does not consist entirely of zeros? It's got to be a 1. Good. Okay, what is the difference between Gaussian elimination and Gauss-Jordan elimination? Gaussian elimination, you're essentially getting the matrix into a row echelon form. Gauss-Jordan elimination, you're getting it into a reduced row echelon form. Good. I don't know why it's lagging so much. What 4 properties must a matrix have to be in reduced row echelon form? Okay. Basically, rows that are all zeros, consist entirely of zeros, those are grouped at the bottom. Of rows that do not consist entirely of zeros, the first entry reading from left to right must be a 1. We said reduced row, okay. 2 consistent, not complete rows that are not both all zeros. Yeah. 2 non-zero rows next to each other, consecutive or sequential. The one on the bottom must have the leading one that's further to the right. And then leading ones, the columns that contain leading ones, pivot columns, these must contain all zeros except for the leading one. Okay. Good. What 3 properties must a matrix have to be in row echelon form? Everything we just said, except that the pivot columns don't need to have only the leading one. They can have other digits besides 0 and leading 1. All right. What is the backward phase of the algorithm for solving a linear system by Gauss-Jordan elimination? The backwards phase is when you are eliminating or you're introducing zeros above the leading ones. Good. What are the pivot positions of a matrix? Pivot positions of a matrix are the locations, the entries in which where the leading ones are when that matrix is converted into a row echelon form. Okay, good. What is the trivial solution of a homogeneous linear system in the unknowns x1, x2, ... x sub n? What is the trivial solution? All these unknowns are just equal to 0. What is a pivot column of a matrix? A pivot column is essentially a column that contains a leading 1 in the augmented reduced row echelon. A pivot column is essentially a column that contains a pivot position. Free variables, what are they? Free variables are variables that are not associating with leading ones, or variables essentially that aren't leading variables. Homogeneous linear system is this linear system that all the constants b are equal to 0. What are the non-trivial solutions, if any, of a homogeneous linear system in the unknown? X sub 1, x sub 2, x sub n. Essentially anything in which they are not all equal to 0. Any solution that is not the trivial solution, good. If a homogeneous linear system has n unknowns in the reduced row echelon form of an augmented matrix has r non-zero rows. Non-zero is important. What can you say about the number of free variables in the linear system? Has that many rows and that many unknowns, so I would say it's going to have n minus r unknown, or free variables, n minus r. Cool. That's the deck. Okay. I'm still alive. Yeah. All right. So now we're going to go ahead and grade the work that I did yesterday. I think we only did one problem. All right, we only did one problem. We're going to grade this one, and then we're going to continue doing practice problems after that. So I'll be back in a bit. All right, so I missed the problem from yesterday, but I was very close. The one thing I made a mistake on was I basically took the transpose of A when I shouldn't have, and that's because I'm like, well, these should associate with x1, so they should be lined up, but I forgot that when you multiply the matrix, or I wasn't thinking clearly about it, you take rows times columns, right? So the x1s are actually going to be everything in column 1, because you're going to times that, and times that, so you don't need to take the transpose. So other than that, I had it right. Just took the transpose, which I didn't need to. So now I'm going to continue doing practice problems, and yeah, I'll be back in a bit. That's called the matrix form of a linear system, by the way. Not an augmented matrix, the matrix form. All right, I'm going to go do more practice problems. I'm actually going to do one from one of the old lessons, so I'll be back in a bit. So we've spent the whole time today doing one single problem that's taken up 1, 2, 3, 4 pages so far, and basically it's from 1.2. It just says solve this linear system via any method. So we're trying to use Gaussian eliminate, or we're trying to use Gauss-Jordan elimination by hand right now, and it's taking forever, but we're getting close. It's not, they're coming out as fractions at this point, so that's kind of ass, but yeah, hopefully we can finish this one tomorrow and get it right. That would be a great step. It's a huge problem. I mean, it's four unknowns with 4 equations. So these matrices have 20 items in them, 20 entries. Yeah. I mean, we're doing our best. We've gotten down to 3 leading ones, working on the last leading one right now, or in the next step, and then we'll do the backward phase. Basically be done as long as we didn't make a mistake, but the chance of making a mistake here out of everything we've done, like one arithmetic mistake, is pretty high. But that's it for today. I'll talk to you guys later. See ya.